Okay, what do I do? What do I do? What do I do? We got Sam.
Put -2 in
for all the x's. Wherever there's an x in my function, I put a -2 in for it. So that would be -2 cubed minus 5 times -2 squared plus 3 times -2, then minus 10. Yes'm? -2 cubed is -8. -2 squared is +4 times -5 is -20. 3 times -2 is -6. Well, that's lots of minuses. So I get here that f of -2 is -28, -34, -44. Yes'm? Yes. Okay. Then, plug it in 3, same thing. 3 cubed minus 5 times 3 squared plus 3 times 3 minus 10. A lot of side chatter going on today. Sometimes I like side chatter, sometimes I don't. Remember, if you're side chattering, I got no problem if you're side chattering about the problem that we're doing. If you're side chattering about other things, then we got issues. Okay? So, f of thrice, that's going to be what? -18, -9, -19. Right? Okay? Beautiful. Okay? So, out there, there's something called synthetic substitution. It's an easier way to substitute the value in. So, same function, same values. Okay? What we do up here is this is the plug in number. These are the polynomial's coefficients in order. Remember yesterday we were talking about placeholders? If we didn't have an x squared term, let's say, we had to fill that squared term in with 0x squared. We would also have placeholders in there too. We have zeros if a term didn't show up. Okay? Then, to simply do the substitution the synthetical way, I take this number and I drop it like it's hot. Okay? Then I multiply those two. And I put it right there. Then I add those two numbers. Multiply those two. Put it there. Add. Multiply those two. Put it there. Add. So this is saying then that f of 2, f of negative 2 is negative 44, which we just found using regular substitution. Now we proved it using synthetic substitution. Drop, multiply, add, multiply, add, multiply, add. F of 3 is negative 19. Okay. Try those two using synthetic substitution. So my plug-in number is negative 3. My coefficients are 1, negative 6, positive 5, and 12. So I get f of negative 3 is negative 84. Concur? Okay. I get f of 4 is 0. Concur? Yes. Since I know the fact that f of 4 is 0, what else can you tell me about 4 or something else in regards with 4 and this function? What? 4 is not a factor. What? But 4 is a 0, right? What else do we call it? Solution? Root? Answer? Okay. What is the factor if it's not 4? Think back to yesterday. What would the factor be?
It's supposed to be like x plus a number.
Okay. In this case, it would be what's the factor? If 4 is the 0. Nope, that would be x, or that would give me negative 4 as a 0. X minus 4 is a factor. Remember, we got to think oppositely because it's inside a set of parentheses. Okay? So we know that. All right, let's try this and see if it works this time.
Wow, you guys really love that old school long division of polynomials. What if you had a fancy way? Yeah, like ketchup, right? I'm talking about maybe motor oil. Synthetic motor oil? No, synthetic division. Yes. Here's our topic. Right. What do we need to do? We need to be divided by special linear factors in order to use synthetic division. So let's talk about how we're going to get into this game. All right. Special linear factors. Yeah, something like these guys. Okay. This is not a special linear factor. Why? Because my leading coefficient of my variable is not 1. What makes a special linear factor? A special linear factor has coefficient 1 and degree 1. An example of a special linear factor is x minus 2. Okay, this is x minus c. Okay, what goes outside of our box? The opposite of c, or whatever's going to make our denominator 0. I'm ready for an example. Up here. Yes. Am I divided by a special linear factor? I am. So then, okay, zeros go outside of the box. What makes that denominator 0? Minus 1. Zeros go on the outside. Coefficients go on the inside. Coefficients are the numbers in front of the variables. Here we go. I'm going to put a 1. I'm going to put a 3. And I'm going to put a 2. Oh, this is actually long division without the actual coefficients, and we need our special linear factors. So then what do I first do? Drop it like it's hot, drop it like it's hot. Minus 1 times 1 gets me a minus 1. Very nice. 3 minus 1 is 2. Okay. Minus 1 times 2 is a minus 2. Oh, and our remainder is 0. What does this mean? This means that x minus 1 is a factor of x squared plus 3x plus 2. You're going to be using something called the factor theorem to determine that. Yes. But that's neither here nor there. Where is it? Yes. We're taking 1 degree out of the numerator. It was a degree 2. So now I want to write my answer as 1 degree less than 2, which is 1. X plus 2 is going to be the quotient of those two polynomials. And then what? And a flower. Now look here. Okay. Yes. Am I dividing by a special linear factor? Yes. So what goes on the outside? Zeros go on the outside. What's a 0? Anything that makes that polynomial 0. What's going to make this polynomial 0? 1 is. Okay. And a different color. Yes. 1 is on the outside. What goes on the inside? My coefficient. Yes. A 1 goes in there. A 2 goes in there. A minus 3 goes in there. And a 12 goes in there. Okay. So then, I drop in it like it's hot, drop it like it's hot, you know, Snoop, dun, dun, yeah, whatever. That was my song with one of my ex-girlfriends. Yeah, and yeah, I went away, and I'm not gonna finish that story. Anyway, she dropped me like it was hot. Oh, messed up, right? She was a horrible person. No, she wasn't, really. Yes, here's a 1. This one
Best
times
part
that
of
one,
the
put
whole
it there. That's a 1. 2 and 1 is 3, Tiki. This one times that one, put it there. That's 3, Tiki. Adam. None. Yes, this one times that one, put it there. 0. Oh, Adam, and you got 12. Oh no! What does this mean? Let's go through and rewrite our quotients. Yes, I had degree 3. This is gonna take it down a notch. I wish you'd take it down a notch. Hey, whoa. So instead of degree 3, it's now gonna be degree 2. So then, this is gonna be x squared plus 3x plus, no constants, but I do have a remainder. And how do I write that? I write it remainder over divisor x minus 1. Fun. And then what? And a flower. And when I said I went away, I wasn't talking about like to the woohoo. Yeah, no, I had to go, do some work somewhere else. Here we go. What makes this denominator 0? 2. Yes. So I put a 2 on the outside. And then I put the coefficients on the inside. I put a 1. Then I put a 0. Why? Because I need a placeholder for my x to the third term. Yes. So 0x to the third plus 0x squared minus 1x plus 2. Okay. Oh, I need placeholders. On the outside, zeros. And then on this first one, drop it like it's hot. There's a 1. 1 times 2 is 2. Very nice, Adam. 2. 2 times 2 is 4. Short, Adam. 4. 2 times 4 is 8. Great, Adam. That's a 7. 2 times 7 is 14. Adam. That's a 16. Okay, that's my remainder. I'm dividing by a linear factor. I need to take it down a notch. This is x to the third plus 2x squared plus 4 x plus 7 plus remainder 16 over divisor x minus 2. Look at that one. Oh, yes. Yeah, I do think it's a hammer. Because it's hammer time? No. Because we nailed it.
Alright, so, in that last problem, since f of 4 equals 0, that means x equals 4 is a root, is a 0 is a solution of f of x, and we said then that x minus 4 is a factor. We can use synthetic division then to find the other factors of that polynomial. Okay? So, we can synthetically divide. Oops. So there is my 0. As the video just said, zeros go on the outside. Coefficients go on the inside. 1, -6, 5, and 12 are the coefficients of my polynomial. Drop it like it's hot. 4, -2, -8, 3, -12, and 0. Okay? So, if it's the first stop on our bus route, we would just straight up divide it out. And if it's the first stop where we just divide these two, okay, then this answer here would be x squared minus 2x minus 3. So if the directions say divide these two polynomials, that's going to be what your answer looks like. Okay? However, if it says go on to step number 2 and factor, see if I can yank this up now, and factor these completely, now because this 4 is a 0, f of x here is equal to x minus 4 times x squared minus 2x minus 3. And I look now at that blue trinomial and I say to myself, self, can I factor that some more? And the answer to that question is yes. It factors to be what?
X plus 1 and x minus 3.
Bingo. And so this would be bus stop number 2, the factored completely stop. And then we could go on to bus stop, boy, I went way down with it, to bus stop number 3, which is find all the zeros or the solutions of it. Well, I'd have to divide out a factor or a 0 that I know. I'd have to factor it completely. And then once I have it factored completely, then I would have to set each of my factors equal to 0. Then I would solve all of those. And then my answers down here would be negative 1, 3, and 4. Okay. Directions matter because the directions are going to tell you where to stop. Sometimes it's going to say go all the way through to bus stop number 3. Sometimes you got to get off at the first stop. Okay? Directions matter. So, given this polynomial, and the fact that x minus 3 is a factor, I'm asking you to factor this polynomial completely. Okay? So if x minus 3 is a factor, what's the 0? Because zeros go on the outside of our synthetic division. So if x minus 3 is the factor, what's the 0? How'd you come up with 3? You set the factor equal to 0, and you solve for it. So the 0 goes on the outside. 2x cubed minus 11x squared plus 3x plus 36. So those go across the inside. drop it, multiply it, add it, multiply it, add it, multiply it, add it. Should have I gotten 0 there at the end?
Yes.
Yeah, because it told me that it was a factor already. If I get something other than 0 on the end of something that I was told was a factor, I either did something wrong or the person's lying to me. Okay? So how, or my question now is, how can I rewrite f of x so far? F of x is what times what? What's a factor of f of x? X minus 3. So f of x is x minus 3 times what?
2x squared minus 5x minus 12.
Love it. These are my new coefficients. So I take the degree down a notch. So it went from 3 down to 2. So it's 2x squared plus, or excuse me, minus 5x minus 12. Okay? Can I factor this?
Yes.
To what? What multiplies together to be 2x squared?
1 and 2.
So 2x and x.
Yeah.
What multiplies together to be 12?
6 and 2.
4 and 3, 6 and 2, 1 and 12, right? Okay? So, do any of those combinations work? 4 and 3, which one gets the 4, which one gets the 3? Left to right. 3 first or 4 first? 3 first. Signs. Plus minus. So you're going plus here, minus there. Okay? Outsides gets me negative 8x. Insides gets me positive 3x. Together that gets me negative 5x, which is what I want. Last gets me positive 3 times negative 4 is negative 12. So I would concur that that's how that's factored. So the complete factorization of my polynomial then is going to be x minus 3, 2x plus 3, and x minus 4. And that's where I stop. If it said give me the 0 solutions, roots, whatever, I would go on and then I would say x minus 3 equals 0, 2x plus 3 equals 0, and x minus 4 equals 0. Okay? You try that one, dividing using synthetic division.
How about you're dividing?
So that's my factor, right? I don't know if it's a factor or not because it didn't tell me in the problem, but I still treat it like 1. So then this becomes x plus 2 equals 0. So then that's going to give me x minus 2 as my possible 0. Okay? So negative 2 is going to go on the outside. My coefficients of 1, negative 1, 4, and negative 10. 1, negative 2, negative 3, 6, 10, negative 20, negative 30. So was it a 0? No, it's not a 0, but that's okay because this was bus stop number 1. It's just asking me to divide. Right? Okay? So the answer here then is going to be, this started as a cubic, so this drops down to a squared, minus 3x plus 10 plus negative 30 over x plus 2. Okay? Try that. Okay? So here's my factor again, which means then 2 is my 0. So 1x cubed plus 0x squared minus 5x plus 3. Gotta have that placeholder. In long division, you can actually get around not having the placeholder. Okay? You just have funky math and things aren't lined up. Okay? In synthetic, you cannot get around having that placeholder. If you don't have it, your whole problem is going to be off. Okay? So this is 1, 2, 2, 4, negative 1, negative 2, and 1. Kiana. So this ends up bus stop number 1. This is x squared plus 2x minus 1 plus 1 over x minus 2. Okay? Find all of the zeros of the following polynomial given the fact that x minus 3 is a factor. So, that's a factor, which means then that x minus 3 is going to equal to 0, so x is going to equal 3. So x equals 3 is a 0. Two, negative 11, 3, 36. Two, 6, negative 5, negative 15, negative 12, negative 36, and 0. Some of you are just realizing that this was like 3 examples ago. Okay? But it's not. Because 3 examples ago, we stopped at bus stop number 2. Right? Now we're stopping at bus stop number 3. Yep. Okay? So it is the same up to a point. This time now, we just have to go further. So f of x here is equal to x minus 3, and then 2x squared minus 5x minus 12. Then we rewrote that as f of x equaled x minus 3, 2x plus 3, and x minus 4. That's where we stopped before. That was factored completely. But now, this problem is asking us to find all the zeros. So we have to go another step further, and we have to say x minus 3 equals 0, 2x plus 3 equals 0, and x minus 4 equals 0. So I get here that we have zeros at negative 3/2, positive 3, and positive 4. Okay? Tonight I have a worksheet for your homework. It is one of the 4 homeworks that will be due on Monday. Don't freak out. I put it on a separate sheet of paper or a separate color, I should say, for a reason. It looks strikingly similar to yesterday's worksheet, but it is different. It is different problems. It is different methods. Sorry, Jared.
Okay.
Okay, so you got 4 worksheets due, quiz on Wednesday, and a formative on Tuesday.